Okay, in this lecture we're going to discuss how to solve equations that have radical symbols in them. Now, we base this upon what's called the power property, which basically says this, right? If P is a algebraic expression, right, and Q is an algebraic expression, and these two expressions are equal, then this will have exactly the same solution as if I take the nth power of P and the qth power of P. So in other words, we can take the power of both sides and it gives us the same solution for any positive integer n. Alright, so be very careful with the power property though, because sometimes it can produce a number that appears to be a solution but it isn't a solution. Okay? And it's very essential to check. So let me highlight that right away. It's essential to check your solution. Okay? Alright, let's do an example. Alright, now let's suppose I want to solve, right, part A, x minus the square root of 4x plus 12 equals 0. So notice here's the radical. Right, so step one, we isolate the radical. Right, so in other words, if I add it to both sides, I end up with x equals the square root of 4x plus 12. Okay, so that's step one. Step two now, we look at the radical, and it's a square root. So what undoes a square root? Well, a square. So in this one, step two, we're going to square both sides. So I'm going to have an x squared here equals 4x plus 12 all squared. So really what I have is x squared is equal to 4x plus 12. Alright, and so now step 3, solve for x. So in other words, we have now x squared minus 4x minus 12 is equal to 0 is our quadratic. We're looking for factors of 12, which of course will add up to negative 12, which will add up to 4. So it looks to me like 6 and 2. And of course we will need a negative 6 and a plus 2, so I have negative 6x minus 2x is negative 4x, and I have negative 12. So that tells me that x plus 2 equals 0, or x takes 6 equals 0, which implies that x is equal to negative 2, or x is equal to 6. Now we need to check, so this will be step 4 if you like. Alright, so when x is equal to negative 2, I come back to the original one up here, and what happens? I have is negative 2 equal minus 4 by negative 2 plus 12. Is this equal to 0? That's what I want to know. Well, this of course means negative 2 minus the square root of, what do we got here? Negative 4 plus 12 is 4. And we end up with negative 2 subtract 2. Is this equal to 0? No, it isn't. We have negative 4 is not equal to 0. So this is not a solution. Okay, and now what about when x is equal to 6? Do I have that 6 minus the square root of 4 by 6 plus 12 equals 0? Well, let's see if we do. We're going to have, does that mean 6 minus, let's have a look here. So this is 6 in here, so 4 6 is 24 plus 12 is 36, so square root of 36. Is this equal to 0? Well, I have 6 minus 6 equals 0, so yes it is. So our solution is simply 6. Okay? So be careful of those extra solutions. Okay? Alright, let's do part B. Alright, let's suppose that we have the square root of 2x plus 3 minus the square root of x plus 1 equals 1. Now the problem we have with this one is that we have two radicals here. So again, we need to isolate them. So let's say this would be the square root of this one is equal to, if I add this to both sides, I'd end up with this thing here. Now we have to be very careful here when we're squaring both sides. So that's part one. So part two, when we square both sides, this part's fine, but we are squaring this binomial term, if you like, which means I need to FOIL this. Okay, so this is going to imply that I get 2x plus 3 equals. Alright, now let's do the FOIL here. It's going to be 1 by 1 is 1. 1 by this is the square root of x plus 1. And of course then we do square root of x plus 1 by 1 again, so I'll end up with 2 of these. And then we square this one, of course, I'll end up with x plus 1. Okay, so make sure you understand we're foiling that. Right, now notice we can now get some things together here. So let's subtract x from both sides, so I'll get an x here. I've got 1 and 1 is 2 subtracted, so I'll get 1 here is equal to 2 square root of x plus 1. Now notice that we still have a square root here, so now we're going to square both sides again. So I'm going to have x plus 1 squared, okay, is going to be equal to 4, 2 squared, and the square root, the square of the square root of x plus 1 is going to be x plus 1. Right, so this means that when we FOIL this again, we're going to have x squared plus 2x plus 1, so FOIL here again, is equal to 4x plus 4. So this implies that x squared, subtract 4x from both sides, negative 2x, and we're going to have subtracting 4 from both sides will give us negative 3 equals 0. So again, we have a quadratic and we need the factors of negative 3 add up to negative 2. So I'd say that this would be a 3 and a 1. We need to see which one's going to be positive and negative. So negative 3x plus 1x. So this will be equal to, implying x is equal to 3 or x is equal to negative 1. Alright, so consequently we need to check now. Right, so let's take x is equal to 3. We go back to the original one. So we have the square root of 2 by 3 plus 1 and subtract the square root of 3 plus 1. Is this equal to 1? So what I've got here is 6 plus 1 is going to be, oh, should have a 3 here, sorry. We have 6 plus 3 is 9, so this implies, is the square root of 9 minus the square root of 4 equal to 1? Well, I have, in fact, 3 minus 2 is equal to 1, so yes it is. So this one is a solution. That one's okay. Right, now what about when x is equal to negative 1? Then do we have the square root of 2 by negative 1 plus 3 minus the square root of negative 1 plus 1? Is this equal to 1? Okay. So here we have, of course, negative 2 plus 3 is the square root of 1 minus the square root of 0. Is this equal to 1? Well, yes it is. Square root of 1 is 1, so yes it is. So our solution is both of these. So it's going to be negative 1 and 3 is going to be our solution. So that one is going to be quite okay. Right, so that's how we do equations with square root radicals. And we're going to look at another one, which is a cube root.